Welcome to this third video tutorial of Let's Make a Point-and-Click game for the Atari STe. This tutorial uses the SGDL library available in the description below. In the previous video we initialized the SGDL library with a video mode and loaded a GIF image file on screen. We set up the image palette right away, but we can do better and try a little fading effect. The SGDL library have a function taking care of this. Let's try it. First of all, we will store our GIF palette inside a second buffer. Then we will zero out our main palette buffer. Then we will call our fading function in a loop and wait for the function to return its completion. Each time the function is called, we wait for a frame display to complete, so the fading can be visible. The SGDL set palette function doesn't have to be called each time because it is setting the given palette buffer as a pointer to access the palette. It is not copied when calling the function. Now we will load the cursor GIF image to demonstrate the sprite functions using the blitter chip of the Atari STe. Due to the complex nature of the Atari screen layout, as we discussed in the previous video, drawing a sprite on an Atari screen is pretty complex and require highly optimized assembly function to get a descent speed. The blitter chip allows to simplify this task, and I made a special blitter library simplifying it even further. Remember that all your graphics must be a multiple of 16 pixels width. Now the sprite must have a transparency mask to mask the current screen background with the transparent area of the sprite. Remember the pink zone index 0 of the palette in the sprite. We allocate a buffer for the mask data, and we call the function generate mask from 4 planes to generate the mask data. We want to draw this sprite at the current position of the mouse, so we will set up the mouse system using the function SGDL setup mouse. This function takes the mouse area as parameters. This area will be the area of the screen minus the cursor size. If our sprite is 16 pixels wide, we will use the blit sprite 16 4BPP function that will draw a sprite of 16 pixels width and any height in 4 bits low resolution mode. We call this function with our GIF image data, our mask data, the current screen pointer and the position of the mouse. Now, don't forget to read the header of the functions. For example, in the blitter.h header, you can read that the blitter functions needs to be executed in supervisor mode, because the blitter need direct hardware access. So we will make the whole main function into another function, and call the supexec function to execute the program in supervisor mode. Now we compile this example and try it on the emulator. As you can see, this is working, but the sprite leaves a trail behind it. This is because we didn't restore the background behind the sprite when we draw the sprite at a new position in the next frame. So we will restore the background using a blitter function. This blitter function is blitter copy bitmap 4. This function doesn't work like sprites that can be shown at any position. This function is faster but require to draw image at a 16 pixels position multiple, so you can only draw graphics at pixel position x equals 0 or x equals 16, x equals 32, etc. We will call this function with source as our background GIF image destination. The screen and position is the previous mouse position saved. The position will be narrowed to 16 pixels multiple automatically by the blitter function. The width of the copied area must be 32 pixels because if our 16 pixels width sprite is in between two portions of 16 pixels, they will be both affected by the sprite drawing. The variables of the mouse position can be modified at any time when the mouse moves, so between two calls of a function, the mouse position might have been modified. We need to save the mouse position at each frame and use these position that will not vary over time. Let's watch the result. Congratulations! We have a base of point and click game on the Atari STe with only a few lines of code. In the next video we will use the virtual screen hardware scrolling feature and text font drawing.